Good morning, this is Dr. Turner for Integrated Math 3. Today we're going to be talking about 4.3, rather. That's looking at multiplying and dividing rational functions. This is going to follow the same process that we've looked at with 4.2 and 4.1. We're going to use all the same properties that we would use for any fraction in terms of combining like terms, in terms of simplifying, and then just like with a normal fraction, if we're multiplying, we're going to multiply straight across, and if we're dividing, you can use a number of techniques, but most commonly we're going to do keep, change, and flip. So let's get into what we're going to look at today. So with multiplying and dividing rational functions, as I mentioned, the level 1 examples, if you will, are pretty straightforward. If I have x over x plus 1 times 4 over x plus 2, this is multiplying just like any other fraction set. You multiply straight across. So multiply the numerators, 4 times x, and you'll multiply the denominators, x plus 1 times x plus 2. Depending on the instructor, they might ask you to expand it or write it in standard form. Just be careful with the instructions. If you were asked to do that, that's FOIL or box method. So here you would end up with x squared plus 3x plus 2 by, again, doing your FOIL method, multiplying each of those out. Another example here, negative 3 over x plus 6 times x plus 2 over x squared. This could be in parentheses, it could not. Idea is the same, we're multiplying straight across, so here I end up with negative 3 times x plus 2 over x squared times x plus 6. And if I'm asked to expand that out, I end up with negative 3x minus 6, and in the bottom I end up with x cubed plus 6x squared. And it could be binomial times a binomial on the top, x plus 1 over x plus 3 times x minus 1 over x plus 4. If I'm asked to just simplify it without having to multiply the binomials, you could just write that as a single fraction, and sometimes that'll be helpful if we're trying to simplify the expression. Otherwise, you can multiply it out using FOIL or any other shortcuts that we've talked about in previous units to get x squared minus 1 over x squared plus 7x plus 12. So that's all pretty straightforward in terms of multiplying. Same would be true of division. So if I had x over 4 divided by 1 over x minus 2, for example. Again, multiple techniques we can use, but most common when we're looking at fractions is keep, change, flip. So you keep the first fraction, you change the operation to multiplication, and you would flip that second fraction. Once you do that, you're going to multiply straight across. So here I end up with x squared minus 2x, and in the denominator I have 4. Keep, change, flip. And number 5, say 1 over x minus 3 divided by x plus 4 over x plus 3. So same thing, I'm going to do keep, change, and flip. I'm going to follow the rules of what's written out in the instructions. If I have to simplify that, I'm going to. When I do keep, change, flip, I multiply straight across, I end up with x plus 3, and that's all over x minus 3 times x plus 4. And if I'm instructed to do so, I'm going to multiply those two binomials. So in the denominator, I end up with x squared plus x minus 12. So, like I said, if you have to simplify, you want to, sometimes you can, sometimes you can't. And so usually the directions here will be a little bit vague. They'll just say simply like, simplify if necessary, simplify if able to. So it's up to you to determine if you can simplify or not. But if you can, then you need to do that. So for example, let's look at example number 6 here. Let's say I have something like x plus 3 over x plus 6 times 1 over x plus 3. Here, yes, we can multiply straight across, and because those operations are in a parenthetical, we could write it as x plus 3 over x plus 6 times x plus 3. If you end up with a product, once you're done multiplying or dividing, and you have a common factor, then you can cross out that common factor. So here, I could cancel out an x plus 3, and that leaves me with not 0 in the numerator, but rather a 1. And so simplified, that would be 1 over x plus 6. So anytime we can do that, we need to. Let's look at another example. 1 over x plus 6, and I'm going to divide that by x squared over x plus 6. Using my fraction rules, keep, change, flip. I'm going to keep the first, change the operation to multiplication, and then I'm going to flip the second fraction. By doing so, now I have an x plus 6 in both the numerator and the denominator. So because of that, I can cancel out that common term. X plus 6 cancels, and then multiplying straight across, I end up with 1 over x squared. Even those examples aren't too bad because I can already see that I have a like term, and so it's very easy for me to cancel it out. I can make this a little more complex, especially if I'm giving you something higher than a linear term in one of the fractions. So for instance, let's say we have something like x squared minus 6x plus 9 over x squared plus 4x plus 4, and I'm multiplying that by x squared plus 10x plus 16, and I'm dividing that by, let's say, x squared minus 5x plus 6. So here, that could get pretty messy. As we've mentioned in Unit 3 and 4, because I'm multiplying here a trinomial times a trinomial, I'm going to end up with 9 terms. So if it's more complex like this, typically, if it's in this section, it means I could simplify at least something. So I probably want to write this in factored form. Not the only way you can do it, but it's one way. So x squared minus 6x plus 9 factored would be x minus 3 quantity squared. X squared plus 4x plus 4 would be x plus 2 quantity squared. And then on the right side, that is factorable to x plus 8 times x plus 2. And in the denominator, that could be written as x minus 3 times x minus 2. So yes, there are 4 binomials here in the top and bottom, but I have an x minus 3 on top and bottom that can cancel out, and I have an x plus 2 on top and bottom that can cancel out, and so that would leave me with x minus 3 times x plus 8, and that is over x plus 2 times x minus 2. Again, if the directions say to leave it like that, then you're good. If it wants you to multiply it out, then you would end up with x squared plus 5x minus 24 in the numerator and x squared minus 4 in the denominator. For me, either of these is acceptable, but if you're doing work out of the textbook or if you're looking at supplementals, just be sure to pay attention to what the question is asking you to do. That's all for me for right now, guys. This is just one of those that you're going to need a little bit of practice with. I really encourage you to look at your supplemental resources to get a little bit of extra practice of doing these and simplifying especially. The multiplication division is not too bad. I think it's the simplifying that catches people up, but once you do it a couple times, you get the hang of it. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.